Okay, let's move to the second case where we have the situation where you substitute the value of x into the function, we will get infinity over infinity. So here we have the same procedure as for the LHopital rule. If you got infinity over infinity, then you have to differentiate the numerator and the denominator separately, and then you just substitute the value, whether you get a number or you have failed to get a number. Okay, look at the example 6. Example 6, now we have the situation we want to find the limit of x to the power of 2 or x squared over e to the power of x when x is approaching to infinity, positive infinity. Or you might say this is a very large number, but we do not know what is exactly the value is. And then the first procedure, the first step, we always substitute, right? Okay, x, and you substitute the x is positive, and you square it, and you get something you do not know, right? And very large number. And then we know that e, when you substitute the x infinity, e, you know the graph of exponent when you have the very large number, so the graph goes up very rapidly, right? So the answer also very large number, but we don't know whether they are the same or not, so we just leave the answer becomes infinity over infinity, and infinity over infinity also not a number because we do not know exactly the number is. So here we can use the LHopital rule because we have the situation, the answer when you substitute the value of x is infinity over infinity. Okay, now we look at by using the LHopital rule. Okay, so x approaching to infinity. So what happened to your functions now? Differentiate the x squared, so you got 2x, and then differentiate the denominator ex, so you got ex, and then after that we replace the x into the new version of function, so we still get the infinity over infinity, but still infinity over infinity. Then for the second time we use the LHopital rule again. Okay, don't worry how many times you can use, as long as you got infinity over infinity or 0 over 0. And x approaching to positive infinity, and then we have to differentiate the latest version. The latest version of the function now is 2x over x, then we have to differentiate them separately. 2x becomes 2, and then ex, and then we substitute the value 2 over very large number. Okay, remember 2 over very large number, and when your denominator is very large, so it's approaching to what? 0, right? Okay, so 0 is the number. Then we can conclude that by using the LHopital rule, we can find the limit of the original expression x squared over e to the power of x when x approaching to infinity and the function is approaching to 0. How about the convergence of the function? Since the limit does exist, we can say the function is convergent. Okay, let's move to the example 7. So example 7, limit of ln x squared divided by x when x is approaching to infinity. Then let's substitute the value ln infinity square over infinity. Okay, you can check what happened the value of ln when you start with the ln 1, ln 100, ln 1000, ln a million, and you can see the value of the ln when you substitute into your calculator, the answer becomes larger and larger, right? So here we can say because something very large number divided by also a very large number, and it turned out to be infinity over infinity case. Here we can use the LHopital rule. differentiate them. So ln x squared 2 ln x over x. That's the answer for the numerator. The numerator here, we have a multi-layer of expression. Then here means you have to apply the chain rule. Okay, so differentiate the outer, you have square, and you got 2 in front here, 2, and then differentiate, and then ln x to the power of 1, and then differentiate the inner, you got ln x, right? Differentiate the ln x, you got 1 over x. Next, you differentiate the denominator x, so we got 1. Meaning that you want to find the limit of x approaching to infinity. So now we have ln x over x, and we substitute the value what we got here. Alright, still infinity, ln very large number over infinity. Then we need because of still we get, due to the case we have infinity over infinity, then for the second time, sorry. And then you can apply the LHopital rule again. And then differentiate the new version of your expression now. This one, limit when x approaching to infinity, differentiate ln x, you got 1 over x. Differentiate x, you got 1. And then you substitute the value 1 divided by very large number, and the answer is approaching to 0. So means that, okay, why should I continue there? Can I continue here? Okay. Meaning that we can say that the limit, can I use a different color? Okay. So the limit of the original expression ln x squared over x, when x is approaching to infinity, we got 0, and since the limit does exist, so the function is convergent. Okay, so I hope that you're very clear with this. So we got quite number of examples here, but if you're still unsure, you should ask me or you can ask your friends.